This presentation is part 2 that continues the topic discussed in part 1, but where we look at the actual Python interpretation. In part 1, I covered the problem of how to deal with several languages. And then we came to the conclusion that we will have one model which will be used to process multilingual datasets. And so now we will take a look at one possible way of working with that type of one model. But before I look at the implementation and explain the main idea, I have to cover an auxiliary issue. And that's the fact that when the theory becomes more complex, more realistic, and the dataset becomes more realistic and involves real linguistic phenomena, the theory itself will eventually consist of several modules, several cognitive systems. So it is not going to be just some kind of one package or bunch of rules, but rather there will be several more or less independent systems. Things like lexicon, morphology, semantics, possibly the semantics itself will be divided into several submodules or systems. Syntax, and in the domain of syntax it's also possible, perhaps even likely, that there will be several submodules or subsystems, so it's not just one assembly mechanism. And then obviously we will have phonology, morphophonology and other interfaces between these systems. So we are going to be building eventually a modularized or modular system. Here is just an illustration of what it could look like. This is from my own model I'm using in my own research, but this image is a bit older, a couple of years old, but it gives you an idea what we are talking about. And when I'm going to look at the source code presently, I'm going to show you how you can implement a modular system like this. But the main point I wanted to discuss this background is that whatever your theory of the division between biological and cultural components is, that is something that will eventually manifest or concretize, or what's the right word here? That's something that you will eventually implement or translate into this type of framework, so that the language-specific parts will be either some whole modules in your overall theory, or some properties or parts of some of these modules. And some other aspects are going to be biological. For example, it could well be that this type of overall architecture, as I'm showing here, the modules and their connections and the information flows between them, is going to be part of the biological reality. So this is all going to be described in the universal biological part of the one module that we will be developing. And then some of these parts or some aspects of these parts will be will change from language or from speaker to speaker. For example, I already mentioned that there is no doubt that the vocabularies or the lexicons will change from language to language, and the lexicon is just one part of this architecture here. It's described these modules here in the posterior left or dominant hemisphere, posterior and dominant hemisphere. Now this, let's just introduce some terminology before I look at the source code. So this whole object I showed with all these modules It's called, or I call it as speaker model. The speaker model, to be precise, is what results when we take this biological architecture and whatever biological components we have on our theory and combine it with the cultural properties or cultural aspects that have been acquired from the environment, from the linguistic environment. So it's like this. The speaker model for some language, or more detailed, is more precise, it's for the group of speaker model for the group of speakers is the universal part plus the language specific part, specific for that group. Now I'm just going to talk about languages, but this same point applies whether we're talking about child languages or language pathologies or anything that can be characterized groups of speakers, or perhaps even an individual speaker if we have somebody who has very extraordinary profile, behavioral profile. So, and that is the speaker model. We have this both field, and this in turn now means that when we change the language in the dataset, when we shift from one language to another, what's going to happen is that we are going to shift from one speaker model to another. Finnish data will be processed by the speaker model for Finnish, English data by speaker model for English. So that's the logic. I will show how we create the speaker models in the level of code next. But first, a brief comment of how the implement. So now I'm going to move into the Python. The main idea is that this speaker model here is defined in its own class. I will just call it speaker model, the class itself. And the actual speaker model objects will be the speaker models for different languages. And each concrete speaker model object, when it's created, will fill in all the required language-specific properties. For example, the lexicon. So this architecture I'm showing here, the architecture itself, all the modules with the connections, etc., this is defined in the class definition. And then the language-specific properties are filled when we are creating the speaker model objects. And these objects are used for the actual processing of data in the dataset as a function of the language, what is present in that set. And the speaker model class is a composite class, which is made by other classes / modules which describe all of these subsystems here. So the speaker model is a composite class which contains these separate modules, each defined in its own class, separate class and separate module. And then when we have further distinctions, let's say semantic interpretation number 10 here, if that is broken down into further submodules, those distinctions are described in the semantic submodule as it exists here. So the composite class for speaker models will contain these higher level modules, and if they are divided internally into further submodules, then these higher level modules themselves are composite class of these even lower level systems. So that being said, we can now go to look at the implementation and give an idea how you could do all this in Python. So here we have a separate class called speaker model which is in own module, and this is the class which will define the general architecture I just showed. So now, of course, I am not going to go through everything I have here. Most of this is irrelevant to the topic at hand. But one of the key properties here, well, we have first of all settings, of course, and I ignore that. But the language is an important parameter that each speaker model will have. And it's a little bit misleading now to speak of language, because what I'm really meaning is that each speaker model represents some group of speakers. And I'm using the language parameter simply because so far I have only been studying speakers of different languages. But if we would have speakers of dialects or child language or whatever or language pathologies, then that would be language in this sense. Really, it would be better to talk about behavioral profiles, maybe. And here you can then see that the speaker model definition is followed by these submodules, because as I just explained, this is a composite class. So here we have semantic component, lexicon, and logical form, which handles the interface between syntax and semantics. Lexical stream, which is the module which is sending lexical information into syntax. Plausibility metrics that takes care of real-time parsing decisions, trying to predict what the intended sentence should be saying. This model is more a comprehension model, so I will using this kind of psycholinguistic plausibility principles, parsing principles. And then there are experimental functions, that module I use when I try something really experimental, especially when I want to compare two versions of something. I can write these versions into that module before I bring them in as part of the theory itself. And whatever modules your system will have, you will just add them here as a composite modules of the speaker model. Now, the main point is now that the language parameter, which I defined here, will trigger when I'm creating this speaker model. This can create, or this will create the required changes in the speaker model when we create something that is specific to a particular language. For example, it will load lexicon. I show you soon how this is done. But how this is done when I create these objects at runtime. But this language is a key parameter, because here, by using this parameter or input argument, you can control how the various modules will change when you create actual objects. For example, what type of lexicon will be loaded, what type of lexical elements we are going to use. And if you have a parameters, the language can also direct the object creation, the speaker model creation, by adopting the parameters that fit any particular language. And same for the language-specific rules, if we have those in the model. Where would these parameters and rules be? Well, I would put them into separate external files. So there would be a file called Finnish profile, for example, and this file would contain whatever language-specific rules or parameter settings the speaker model would need. And this is because when they are in external files, they would be easy to change and experiment with. I would never code them directly into the source code. I actually had something like that at some point, that all of these things I had to use some parameters, and they were written into the code itself, and that never worked because they confused so many things. I was never aware of whether something was happening because there was some parameter changes somewhere, or in the or maybe there's a mistake in the lexicon or the universal rules, or so it became very problematic. And then another problem was that this kind of code was still type of external. I forgot that these principles were there when I was trying to debug and change the models. I forgot that, I had some features in my lexicons and then some rules in the code, in the model itself, the grammatical rules. And I just couldn't get the right behavior out of it until I remembered, but I had these parameters which were doing autonomous changes. So it would be better to have this thing in external files and not to hide them into some corner of your implementation. Well, there are many other properties as we can see here, but that we can forget. The main idea is that add all the language-specific properties to each speaker model. But now we can look at how I'm using these speaker models and how they are actually created. And that's basically all I wanted to discuss in this presentation. So here we have a function which is setting up experiment. Setting up experiment means that this is function that will be executed before any dataset is processed. And what we have is not empty, but we will have a dictionary where the keys are the languages, and each key in the dictionary points to speaker model. So there is a dictionary with keyword Finnish, and that will point to the Finnish speaker model. And here is a simple loop where we create these speaker models. So we go through all languages that we have, and then we simply create a speaker model for that language here. And notice how we give the language as notice how we give the language here as an argument for the speaker model, as I just showed. So this code here will create those speaker models and run the code I was just showing. And then there is an initialization function which does some kind of initializes some variables and makes this speaker model, makes it ready for use. That's what happens there. Now, where do we get these languages? Well, here before I had this kind of object called language guesser. And this is simply a small module which is handling all the languages. And it looks into the lexicon and looks the language variables there, and then creates a language for each language variable. So if I have words from Finnish, they are all marked as Finnish, then there will be only one speaker model. If I add words for English, then automatically this loop here will create a speaker model for English or whatever language. So simply when I add words into the lexicon and I designate them as belonging to some language, then automatically here we will create a speaker model for that language. And then when I'm processing, well, let's look at the actual processing, what happens then there, and I will conclude with this. There's a run study function here, and this is clearly something that's not very optimally programmed. There was some problem when I was, never mind. This is a loop which goes through all the data items, all the expressions I have in the data set. And this is recognition grammar, so now I'm just taking sentence by sentence. Then next, we find out the language for each sentence, and this is done by looking at the words in the expression and determining from which language they come from. And I think it was that the language which donates most of the words will be the language will determine the speaker model that will be used. But if you want, you can also label its expression with specific language and do the selection explicitly in that way. And then here we will simply take this dictionary of speaker models and we pick up the speaker model based on the input language here, and then we will use a function which parses the sentence, or this is the activates the derivational search function for a recognition grammar, which I will be looking at this type of derivational search function in a later presentations. We don't need to care about this. If you have enumerative grammar, here we will simply try to activate the derivational search function. That's what's happening here. But notice that we will, the derivational search function is part of the speaker model. And each speaker model for each language we have will have its own derivational search function activated here. And then it gets in, as it's at its input, it gets the data item, which could be simply the sentence, but any other things that the data might contain, let's say binding information, for example, as I showed earlier. And then we just save the output. So this code comes from my own theory that I'm using currently. So this is not just a simple example script. There is some image. And basically that's it. That's relevant for us to look. So what did I just show? We create speaker models for each group of speakers, typically for languages. Each model contains universal biological assumptions and parts, and combined with language-specific parts. And when we create the speaker models, we give the language as input, and then the function which creates the object will take that parameter into account and fill in the language-specific properties that we will have to specify somewhere, most likely in some type of external file. Then we have constructed the speaker models. When we process the multilingual dataset, we will simply change the model based on the language we have in the input expressions or input sentences.